Section 9.2, Reflections. Reflections result in opposite orientations. Two figures have opposite orientations if the corresponding vertices of the preimage and image are read in opposite directions. So as we look at this example, we would read this BUG going clockwise, where the images, in order to keep the corresponding pieces named in the same order, would be B prime, U prime, G prime, but they would be read counterclockwise around the shape. That's what they mean by opposite orientations. A reflection across a line M, called the line of reflection, is a transformation with the following properties. If your point is on the line of reflection, then it is its own image. So in this case, A is the image and the preimage. If the point B is not on the line, then the line acts as a perpendicular bisector between the 2 points. Basically what they mean is if you start with B and you have your line of reflection, all you're doing is you're moving perpendicular to the line of reflection a certain distance, and then you're going to move the same distance on the other side of that line to show your reflection. So these two measurements should be the same. If you started with B as your preimage, B prime is your image over here, is the same distance away from the line of reflection, just on the opposite side of it. When we write a reflection rule, we use a capital R followed by the line of reflection and then whatever we're reflecting. In this case, it could be a triangle, could be a point, could be all kinds of shapes. All right, so it's capital R followed by the line you're reflecting across. So point P has the coordinate 3, 4. What is the coordinate of P? What is the image of P after you reflect across the line y equals 1? So we start with 3, 4 is our point P. Then we need the line y equals 1 is the horizontal line at 1. So we want to reflect across this line here. So what we do is we move perpendicular to that line, so we'll move straight down 3 units, and then we move 3 units on the opposite side of it. So that means P prime should be right here. And so P prime has the coordinate 3, -2. Problem 2, point M has the coordinates -3, -3, 4. So M has -3, 4, so we go -3, 4, so we put M there. N is -2, 1. So we've got N and M. What are the coordinates of the image of Mn? So in this case, we're looking for M prime, N prime, reflected across the line x equals 1. Well, x equals 1 is the vertical line at 1. So it would be this line here. And so to reflect across this, we're going to move each point perpendicular to that line. So for M, we move over 4, then we extend 4 on the opposite side, and this is our M prime. For N, we move 3 to get to the line, and then we move 3 on the opposite side. So this is N prime. So that means this is our image, and our points, M prime has the coordinate 5, 4, where N prime has the coordinate 4, 1. Here we want to graph the points A, -3, 4, B, 0, 1, and C, 4, 2. So we'll graph those first. So A, B, and then C. And this time they want to know what is the what is the image of ABC reflected over the y-axis? So remember, the y-axis is your vertical axis. And so we will reflect across that. So for A, we move over 1, 2, 3, then 1, 2, 3. So A prime is here. C will move back 1, 2, 3, 4, then 1, 2, 3, 4 to the left. So C prime is here. And since B lies on the y-axis, it stays put, so B prime is here. So this is our image of ABC after being reflected across the y-axis. So your coordinate of A prime should be 3, 4. B prime is still 0, 1. And C prime in this case would be negative 4, 2.
I do exactly what I do.
Graph points x negative 4, 3, y 2, 6, and z negative 1, 6. And then we want to graph and label the reflection of x, y, z over the line y equals negative 1. So negative 4, 3, 2, 6, which is slightly off the graph, I think. Nope. There we go. And then z negative 1, 6. Negative 1, negative 6. Oh. And so we want to reflect across the line y equals negative 1. Y equals negative 1 is this line here. And so we're going to reflect each of these points across there. So for z, we'd move up 5, we move up 5, then we extend 5 on the other side. So z prime is there. And z prime has a coordinate of negative 1, 4. And then for x, we'd move down 4, move down an additional 4. So x prime is here. And so x prime has a point of negative 4, negative 5. And last but not least, y, we'd have to move down 7. Then we extend 7 more, which takes us 2 points off the grid. So y prime is there. Y prime is the point 2, negative 8. And so this is our image of x, y, z after being reflected across y equals negative 1. Trapezoid 2 is a reflection of another trapezoid across one of the given lines. How can you describe trapezoid 2 by using a reflection rule? Well, one thing I know about reflections is the orientation has to be kind of reversed. So I know that 2 is not the result of trapezoid 1 because it just looks more, this is more of a slide than anything else. However, 2 and 3 seem to share a relationship. So if I wanted to describe trapezoid 2 using another trapezoid, I would say that I have a reflection over the y-axis of trapezoid 3. That's how I get trapezoid 2. So reflecting trapezoid 3 over the y-axis would give me trapezoid 2. Each triangle in the diagram is a reflection of another triangle across one of the given lines. How can you describe triangle 2 by using a reflection rule? Well, clearly, triangle 2 is a reflection of 4. So to describe this reflection, I would do a reflection across the line K. And the thing that I'm reflecting would be triangle 4. And that's going to give me triangle 2. So in the diagram, RT, or the reflection across line T is G, equals G. The reflection across line T of H gives us J, and the reflection across D equals D. Use the properties of reflection to describe how you know that this is an isosceles triangle, or that GHJ is. Well, here's the thing. With reflection, if H and J are in the same spot, we know that this measurement, since it's reflected across, should be equal. We also know that, so that tells us that this measurement's equal and that this is all done through reflection. And since it's done through reflection, the one thing we have to remember is reflections, don't change a shape's size. So if that's true, if GJ was one size originally, its reflection, which is now GH, or in this case GH is the reflection of GJ, they should be congruent. Therefore, the sides have to match up. So we should be able to tell that if we were to just say that a reflection across line T of, in this case, let's say we're reflecting GH, should result in GJ, meaning that GH is congruent to GJ, therefore making this an isosceles triangle. Go ahead and work on the wrap-up concept check. Give me the coordinates for the different reflections and the graph and label, and when you're ready to check your answers, unpause the video. So pause it now, work on the wrap-up, and unpause it to see your answers. So for number 1, you should have gotten H prime is -4, -3. For number 2, G prime is 4, 2. And for 3, you see that you have your reflection across the line y equals 4, which is a horizontal line at 4. H prime goes off the grid slightly, but that's okay. But you see that you have a mirror copy of one another because you flip the shape across the line.